Okay, so these are going to be the two power series that we start with when we want to find power series of new functions. So suppose I want to integrate x cubed times the inverse tangent of x to the fifth dx as a power series. Well, what I can do is I can use my power series for inverse tangent of x up here to get a power series for inverse tangent of x to the fifth. And then I can just multiply that, each term, by x cubed. So this will equal the integral of x cubed times, I take each of these terms here, so x, and then I'm going to replace each of these terms with x to the fifth. So x to the fifth minus x to the fifth cubed over 3 plus x to the fifth over 5, etc. dx. And so then what I do is I say, okay, this is x cubed times x to the fifth minus x to the 15th over 3 plus x to the 25th over 5 minus etc., etc., etc. And then I just multiply in the x cubed and I'm ready to integrate. So I get x cubed times x to the fifth, that's x to the 8th, minus x to the 18th over 3, plus x to the 28th over 5, and so on and so forth. Okay, so with that I can find, so now I would just integrate term by term to get a power series for the integral of x cubed inverse tangent of x to the fifth. Okay, suppose I want a power series for x to the fifth, so 1 over x to the fifth plus 1. Well, I'd say, okay, well that's 1 over 1 plus x to the fifth. And so I can get a power series for that by going to this power series and using it. So this is 1 for 1 over 1 minus x. So I would say, okay, well, 1 over 1 plus x to the fifth, that's equal to 1 over 1 minus negative x to the fifth. So I simply go to my power series here and replace each x with negative x to the fifth. So this will equal 1 plus negative x to the fifth plus negative x to the fifth squared, so on. And so then what I would have is 1 minus x to the fifth plus x to the 10th minus x to the 15th, and so on. All right, suppose I want to integrate x minus inverse tangent of x over x, okay, dx. So what I would do is I will first input the power series for inverse tangent of x. So that would be x minus all of this. So that's all divided by x dx. Okay, and so now what I'll do is I will distribute this negative, so I'll do x minus all of these. So x minus x is just 0, so I have the integral of, so that goes away. So then I have negative x cubed over 3, so that's x cubed over 3, minus x to the fifth over 5, plus x to the 7th over 7, so on, and all of that is divided by x. And so then I'm just going to take each term here and divide it by x. So that would equal the integral of x squared over 2 minus x to the 4th over 5 plus x to the 6th over 7 and so on. Okay, so these are the kinds of things that we do. We don't have to integrate and differentiate every time we have a power series. I will always look to see, can I use an existing power series and just substitute something into it to get a power series for the one I want. Okay, and if I have some polynomial minus a function, I'm just going to substitute that function with its known power series and do the polynomial minus it. And then if I have an x in the denominator, then I'm going to take each term, so go term by term, divided by x.